So in conclusion, this direct test or indirect test is not provide direct strength to the rock. So but then we can use the correlation to get the strength of the rocks. So the strength that we get from this indirect test normally is less accurate, but the test is easier and cheaper. Then the instrument is portable and normally it's easy to handle. And then the sample preparation is minimum, very minimum. Then we can use irregular samples, shape for point load test, and rock surface also can be irregular. So the rock, some of testing or in that test is non-destructive, so we can use again the sample for other tests. Even this strength that we get from this index test not accurate, is less accurate, but since we conducted in a large number of samples, then we can improve the strength because we can get our average strength of the rock, so it can get a better estimation of the rock strength. So next testing, rock testing, we call that direct test or strength test. Indirect test or indirect test also, we try to get strength of the rock. So but here is direct measurement of rock strength. So normally the direct test is involve preparation of sample that have specific size and shape, and normally the test is conducted anti-failure, and normally the equipment is quite bulky and expensive, and comparatively, and the factor normally is more expensive. Among tests that are conducted is permeability test, and use the unconfined compressive test, Triaxial test, and shear test. Normally shear test conducted on the disconnected plane, joint or bedding and foundation. For first test is we discuss on UCS or a Uniaxial Compression Test. This is we need to prepare the samples, so as recommended by ISRM, where we need involve coring to get the cylinder rocks. Then we have trimming, meaning that the bottom here should be flat, and then the size here, the length here, and diameter here. You said length here, as diameter should be as recommended, which is normally our core diameter is 52 mm, and the high L here, or high, call it here, high is twice or triple time from the D. Yeah? So the load will load until failure, and then but the best about this testing, we can able to measure the uniaxial strain, lateral strain, and then when we get this lateral and uniaxial axial strain, then we can get the value of modulus and Poisson ratio. But to get this strain, whether lateral or axial, we have to put some instruments, strain gauge on with our sample like this. So we have to put this direction for lateral strain, here for axial strain. So we have to put our strain gauge on our sample. So and then Then we can able to plot the graph stress strain. Then we can able to plot the get the Young modulus. Yeah. So this is the concept of this UCS. So normally Young modulus is a gradient of at 50% UCS compressive strength, and then the typical value for Young modulus between 3 to 90 gigapascal, and then this depends on type of rocks. So we can measure the Poisson ratio based on this with the strain in radials or axial. Okay, so radial, axial. Okay, radial is horizontal, axial is vertical. So the Poisson ratio of rock between 0.1 and 0.3. So this is typical value for rocks, Young modulus and Poisson ratio. So as you know, see here, this is a type of igneous, quite high compared to sedimentary rock. Shale is sedimentary rock. Limestone is type of sedimentary, but in sandstone is sedimentary rock. Quartzite is metamorphic. Granite is igneous rock. Gneiss is metamorphic. Dolomite is sedimentary rock. Coal is sedimentary rock. You can see, that's why you have to know the rock type, then you able to estimate the value of Young modulus and also Poisson ratio. And then when you do this testing, you able to see this mode of failure. The mode of failure after compressions liquid strength. Okay, unlike rocks, so the failure of rock normally is sudden and explosive, and indicate this brittleness of this material. So this is the machine for UCS test. Normally can use compression machine. Okay, but you can use this compression machine like this with the servo control system is much better. Okay, this is another typical comprehensive UCS, tensile, modulus, point load test, and friction angle for sediments, metamorph, and igneous rock. It's good for. So this type of failure is bulging here like this. It's crushed like this. Okay. And then another testing we call that triaxial compressive stress, which is we introduce another surrounding pressure. Okay, so means we have a confined conditions to simulate the confined condition, and then normally the soil is exhibit as a ductile. So this is the machine. This we have this compression machine combined with the hook cell to generate the confinement stress. So this is a hook cell where inside here we have this sample inside here. So this is how we can introduce the confining pressure to the soil, to the rock. Okay, and then this preparation is similar to UCT, unconfined compressive test, but we have confining stress, and then that test can able to investigate to obtain the shear strength of rocks. C and V value, and then it's important, this parameter important in underground excavation or rock slopes, and also for any heavy structures foundation. Yeah? We use that parameter C and P value in using Triaxial test. And then we have another test, we call that shear test. Shear test is conducted if we have jointed rock, so fractured jointed rock. So that they will use it to get the value of the discontinuity or C value, cohesion and frictions of cut slope. So we can use sample like this size, the 300 times 300, or can use core samples more easily. And then so precaution must be, we have to the problem of this shear test is the sampling issue, because we have to do the sampling on the fractured area joint. So is we have joint like this. So how to get the sample on this fractured area? So this is portable apparatus that you can use for the shear test box. Also this equipment. So this is the look on inside the equipment. So we have this rock sample. So our plane is like this here. So join like this. So we have to look on the shear strength of this rock. So we try to look on this shear test in unconfined sliding. Yeah, this is for unconfined sliding. So this one for confined sliding. Okay, so you can simulate this condition, whether unconfined or confined sliding.